Hi, today we are going to cover on the topic on coordinate geometry, which is commonly taught in the secondary 3 elementary mathematics syllabus. Now let's go through what are some of the learning objectives for this topic. Okay, what you will learn basically, you will learn how to find the gradient of a straight line given the coordinates of 2 points on it. You will find the length of a line segment given the coordinates of its endpoints. You'll be able to interpret and find the equation of a straight line graph in the form of y equal mx plus c, as well as to solve geometry problems involving the use of coordinates. Now, if you were to look at the overview of this topic, it's basically broken down into 4 parts, okay? And for this video lesson, we are just going to cover on gradient of a straight line as well as the length of the line segment, in which the remaining parts of this topic you will learn during class when I meet up with you personally. Okay, let's go through number 1, the gradient of a straight line. Now, we have actually learned this in our lower secondary maths syllabus, where you learned about this gradient is equivalent to rise over run. Now, a gradient of a straight line, okay, is the ratio of the vertical change to the horizontal change. So actually, in short, it measures the steepness or the slope. So the higher the gradient, it means that the slope is much steeper. So what do I mean by that? Now, if you were to look at this diagram, okay, rise over run is equated by the gradient. Okay, so the change in the rise and then the change in the run, okay, will give you the gradient. Now, so basically, if you were to project this triangle onto this graph, okay, and I give two coordinates, coordinates A and coordinates B, okay, so theoretically this triangle at this point, it should be A and this is B, okay. So how do I find the gradient of AB? So basically what you will do is you will use this formula, okay, m is equal to y2 minus y1 over x2 minus x1, where m is equivalent to the gradient of the line. So if you look at y2 minus y1 over x2 minus x1, now we give the two coordinates a and b with their individual x and y coordinates. Okay, so this is the x coordinate, this is the y coordinate. Okay, so we give it a number 1, x1 and y1, and then for the second point we'll call it x2 and y2. So what you do is you take you substitute all the points into this formula and you can find the value of m. Now if you were to look at the respective graphs as shown here, now if you have a line that is sloping upwards, okay, like in this case where the line is sloping upwards in this direction, okay, the gradient will be positive. Okay, so that means if you're climbing up the stairs, the gradient is positive. Now when the line is sloping downwards, okay, the gradient will be a negative value. Okay, now if it's a horizontal line, okay, that is parallel to the x-axis, okay, this is the x-axis, you should know. So if if your line is parallel to the x-axis, then the gradient will be 0. Okay, and if the vertical line is parallel to the y-axis, okay, this is the y-axis. Okay, so if your line is parallel to the y-axis, then in fact the m is undefined. Okay, so let us try some examples, keeping in mind your gradient formula. So m is equal to y2 minus y1 over x2 minus x1. Okay, now find the gradient of the line passing through the following pairs of points. So okay, let us try part A will do. So point A you have 2, 3, point B you have 7, 5. So before even I start to find the gradient, always identify their points. So this is x1, this is y1, this is x2, and this is y2. Okay, so if from here, okay, to continue, so I can then substitute m is equal to y2, which is 5 minus 3 over 7 minus 2. Okay, in which I will get 2 over 5. That's it. Okay, now, so if you were to look at this gradient, this is a positive gradient, meaning line AB should be going in a upward motion. Understand? Given a line like that, as in given the graph, okay, equation of AB should be going up since the gradient is positive. Okay, so if it's negative, then it's coming down. Okay, so okay, I will not do B, you do it yourself. Okay, if the gradient of the line joining the points K5 and 2K is minus 2, find the value of K. So like what I said earlier, okay, always identify the points. So this is x1, y1, x2, and y2. Okay, so gradient is minus 2. So which means minus 2 is equal to y2, which is k, minus 5, which is y1, divided by x2, which is 2, minus k. Okay, so find the value of k. So basically you just cross multiply. Then you should be able to find your value of k. Okay, so you can try this working out yourself. So basically gradient is very straightforward, because what you have to do is just to substitute back into the formula y2 minus y1 over x2 minus x1. Now question 3, okay, if the points P, Q and R are collinear. Now what's the meaning of collinear? Okay, very important. Okay, I put a 3 question mark here, exclamation mark here. Okay, basically collinear means they lie on the straight line. When they lie on the straight line, it is something like that. It means I have a straight line here. I may have 3 points. Point P, point Q, point R. Okay, for example, P, Q, and R. So if you were to look at the steepness of this straight line, it means that the gradient of, okay, I put the gradient M of PQ is actually equal to the gradient of PR, and is also equal to the gradient of QR. Okay, so we say find the value of Z. So basically what you have to do is you can write M of PQ is equal to, let's say, M of PR. Okay, so M of PQ, how do you find Y2, which is this, Y2 minus Y1. So Y2 minus 3, which is plus 3, over X2 minus X1. X2 minus X1 is equal to, okay, then gradient of PR. I can just choose either this and this, or this and this. But in this case, I'm going to choose the first two. PQ equals to PR. So PR will be Z, Y2 is Z, minus 3, which is plus 3, over 8 minus 2. You understand what I mean? Okay, so okay, to make things easier for you, this is x1 y1, x2 y2, and then we have this another point, we just call it x3 y3. Okay, so basically what I'm trying to find here is the gradient of PQ. Okay, PQ. And basically what I'm trying to find here is the gradient of PR, correct, PR. So after you equate these two, when you cross multiply, you should be able to find, okay, the solution of M. Okay, you can find out what is, sorry, not M, the value of Z. Okay, so okay, you can solve this yourself. Okay, so for this exercise, you can also try this attempt yourself sections. Okay, find the gradient of the line that passes through all these points, so A and B. So to start off, always remember to label them x1, y1, x2, and y2, and then you substitute into the formula m equals y2 minus y1 over x2 minus x1. Okay, so for this part, it is all about using this formula. So this formula is really important. You have to memorize it. It's not given during your exams. Okay, so okay, this is a slightly tricky one, but I believe you'll be able to do it, because look at here, the gradient of the line joining 2 points, okay, is 2 over A, and then you find the possible values of A. So you know that this is the gradient of these 2 points, and from these 2 points you can once again label your x1, your y1, and your x2 and your y2. Okay, so I guess you should know what to do. Okay, so this is the same PQR as coordinates. Okay, 3 coordinates, x1, y1, x2, y2, x3, y3, if the gradient of PQ is equal to the gradient of PR. So M of PQ is equal to M of PR. Find the value of K. Okay, so PQ is this one. You find the gradient of these 2 points. Okay, then you find the value of, the gradient of these 2 points. Understand what I mean? Then you equate them together, cross multiply, you'll be able to find the value of K. Okay, so for the first part, I will just end the video here. So basically, what you have learned is how to find the gradient of a straight line, which basically is determined by this formula, y2 minus y1 is equal to x2 over x2 minus x1. And you learn that if it's a horizontal line, if you were to substitute into that formula earlier on, you will realize that the gradient of the line, a straight line, horizontal line, will be 0. And if it's a vertical line, you will get an undefined solution. Okay, and then if it's going up, it's positive, it's going down, it's a negative gradient. Okay, and you learn about collinear, meaning they have the same gradient, okay, because they fall along the straight line. That's why they have the same gradient. Okay, so with that, I will end my lesson. So for this part of the video, you're supposed to finish all the way from the initial example to question 7, in which I will go through review during class on the next lesson. Okay, thank you.